All right, so today we're going to look at something called combined figures. Sometimes I've also seen them called compound figures or complex figures. A lot of different ways to describe them, but basically what they are is a shape that is a combination of several simpler shapes. So to give you an example, something that looks like this, where you could see it's a couple different rectangles stuck together, or like this, where you can see you've got what looks like a rectangle with a triangle stuck on top. But it's basically just a shape that's mixed together. We're going to look at this one right here. I put them on a coordinate plane. But it's the same process whether it looks like this or the other ones. So to calculate the area, which is the space inside it, pretty much you want to first break it up into smaller shapes like quadrilaterals or triangles that you can calculate the area of. So for example, if we look right here, we can see, sorry, it's not the neatest, but we can see right there, there's a square. We can see right here, we could break this up into a rectangle, and then right here, we could see that we have a triangle on the bottom. So then you're going to want to find the area of each of those smaller shapes. So for this one right here, we could say the area, it's a square, so it's 5 times 5 equals 25. And I like to put the area of each one inside the piece. For the next one, we can see this is a 3 by 8. And I should have probably labeled these too. But a 3 by 8, the area would equal 3 times 8, or length times width, which equals 24. And then over here for the triangle, we could see it's got a base of 8, and then the height would be a height of 4. And remember, we would have to think about flipping that triangle so it was flat on the bottom and the height is straight up to the top. And so we would simply do area equals 8 times 4 divided by 2. That's our triangle equation, base times height divided by 2, which is going to give us 16 as an answer. So once we've done that, we're going to take those shapes. The next thing we're going to do is we're going to just add those different areas together. So we would just have 25, 24, and 16. We would add those all together, and we would get 65 for our total area. Okay, 65. And now keep in mind, usually when you're doing this, there's more than one way. There's not just one right answer. So let's say, for example, we looked at this. I'm going to split it again into a square at top with 5 by 5, and we already know that's 25. But then let's say instead we could have cut right here, and so we have a trapezoid right there, and then we would have another trapezoid right here. And so if we wanted to find those, I can think of my dimensions. And for my other one, I've got 7 and 5 and 3. And so then I would just have to use the trapezoid equations, which would be the area equals base 1 plus base 2, or in this case, 7 plus 3 times the height, which is 3, and then divide the whole thing by 2, or 10 times 3 divided by 2. 10 times 3 is 30. 30 divided by 2 is 15. So this one right here is 15. And then for the other trapezoid, we do the same thing. Area equals 7 plus 3, and this time it's going to be a height of 5. And so we would have 10 times 5 divided by 2. 10 times 5 is 50. 50 divided by 2 is 25. And so this one would be 25. And we would see if we added those numbers together, again, we have 25, 25, and 15. And we're at that same total area of 65. So you can solve these in more than one way. As long as you break it into shapes that you know and you find the area, you'll be good to go. So here's one right here where we can see we've got a shape, and we might look at this originally and think, okay, well, I could make 2 triangles and then 1 rectangle in the middle. But alternatively, sometimes you can actually even just think about like, oh, can I turn it into like a mirrored image version of itself, where we can see we've got a trapezoid on top and one on bottom, and both of them have the same dimensions. So you could just put it in the trapezoid equation. You would find that each one equals 18, and so the total would be 36. So then you only have to do one calculation in that situation. And then, or let's say you had one where you had something like this and you split it up and you found you had a rectangle right there and another rectangle right here, but you see that they're overlapping a little bit, and you've got this extra little chunk in the middle, you could still find that you've got a 5 by 6, you've got a 4 by 5, and you could just find the area of each one of these, and then you just add them both together, and then you just subtract 2, which is like the extra overlapping spot. Or for the very final one that you could look at, let's say you had something like this where it wasn't on graph paper, and you cut it into your pieces, and you're like, okay, I'm going to cut that piece into there, and then you've got sort of like these missing, what's that going to be, what's that going to be. You can actually just figure those out just by looking at a little bit and saying like what's left. So from, if this whole length right here from this side all the way to that side is 9, but then from here to here is 5, right? You could see that like, okay, well if this is 5, then this must also be 5, which means that this right here must actually be 4. And then from here to here, we could see that we've got this section is 4, but the whole thing all the way over there is 6. And so we would know that this remaining part was 2. And so then you just have your 8 and 30, 38 would be your total. So however your shape is, you just want to try to think about splitting it up into those parts. You can find the area on, and then you just combine and add those together, and that's it.